Good afternoon. We almost made it. It's almost over. We got a few more talks though, so we're gonna kind of work our way through some of this information. And number one, thank you for staying. I appreciate everybody's attention, everybody's excitement about kind of where we're going within this soil health movement or the soil health industry. I think it's where we need to go in the ag industry. I think if we're not already going that direction, we may be pushed that way. So it's encouraging to me, thank you, to see that producers have led and started this effort from the beginning. So with that, thanks to Green Cover Seed and all of the producers, mainly you guys that are out there fighting the fight every day and making things work for the natural resources of our great country and for your operations. What I'd like to kind of focus on today is really kind of three topics. Let's see if this will kind of work. There we go. I want to talk about some concerns I have that we see within the effort. We were asked to kind of talk about what we see as we work with producers across the southern Great Plains. We work with ranchers and farmers in Kansas and Oklahoma and across the state of Texas. So it was an effort to kind of maybe point out two or three things that we might want to talk about further and maybe rethink a little bit or at least think of a little bit differently. And then we want to talk about some of the experiences that we've had I'm truly inspired when I hear folks like Mr. Hurst and Chris come up and speak about what they're doing with their operations. And what I'll talk about with our experiences one is a case study that I've got 5 years of data on. That is a partnership effort through the NRCS and ARS and Texas Grazing Land Coalition on a ranch, an operation that is owned by ARS. I'll talk about some of that data, and really I'm going to talk about some good things about it, and I'm going to talk about some head scratchers. And I think in the world of research, we learn just as much when we learn what not to do than when we learn what to do. So that's our kind of job, is to make sure that you guys aren't out learning that on your own. So we make the mistakes and learn kind of how to tweak those systems to make them more beneficial for you. And then we'll talk about some of the research that is ongoing at the foundation, the good and the bad. What we've seen, the data is the data. We need to, I think, realize that as an effort, this was a grassroots-led effort led by producers that were making things work on the ranch. Now we need the data to support those efforts. And I'll talk a little bit more about that in a second. And then I want to talk about some really cutting-edge research that the Foundation's working on as we transfer into the outlook. Where are we going to go with this effort in the future? So with that, I want to start by asking you a question. What do you see in this photo? See grass, see trees. What do you see? Same typical kind of thing. I'll tell you what I see. I see a dynamic ecosystem. I see different types of soils. There's going to be different soil changes as you move up these hills. We're going to have different dynamic structures within a forested system and within a grass system. I see multiple ecological cycles functioning. I see the water cycle, the nutrient cycle. We've got all these things going on in one simple landscape picture. And every one of those things is trying to compete with one another. So the plants are competing for sunlight, they're competing for space, they're competing for water. The microbes are jetting and turning over that nutrient cycle. So it's a hugely intricate, complex system. And there aren't any simple answers to fix it, right? Would we all agree that there aren't any silver bullets? How many times have we heard that? I like the quote that Mencken says when he says, "For every complex problem, there's an answer that is clear, simple, and wrong." So if I tell you to go out there and if you just do this one thing, everything's going to work and everything's going to be all right, I wouldn't tell that to my banker, because you're probably you're going to regret saying that. So at the expense of maybe some darts thrown at me, I want to talk about something, and it's got to be said. Let's talk about cover crops. Cover crops we've been using are an absolutely wonderful tool. They are an absolutely wonderful tool that allows us to bring diversity into monocultures, that brings diversity into systems where we don't have it. It helps us to, cover crops help us to build that organic layer, to help recycle those nutrients. There's 1,000 different things that cover crops are useful for. But what I really want to say about cover crops is I want us to make sure that that's our focus. Where is our focus? We've got cover crop workshops now. We've got books written about cover crops. We've got field guides. We're welcoming cover crop farmers now. We've got cover crops as the missing piece of the puzzle. We've got invest in cover crops and it's raise the sunshine. I mean, we're borderline rainbows and unicorns. I think we need to refocus on what we're really doing with those cover crops. Just because you're planting cover crops does not mean you're managing for healthy soils. It's more than that. It's not the one thing. Look at this conference. This conference is led by Green Cover Seed. It's not the Southern Cover Crop Conference. It's the Southern Soil Health Conference. They get it. They understand that it's a complex system that we're working with here. So, what I'm trying to say, I'm not trying to knock those books. They're absolutely wonderful, and they're full of 1,000 pages of really, really good information. But I want us to focus on a picture that's bigger than what we're going to plant. Now, Mr. Hurst gave an outstanding presentation of how he implements the soil health principles. This is what we really need to be focusing on. How are we going to address the complex, complicated issues that producers deal with from a systems approach? How are we going to address each of these management principles? And planting one crop is not going to do it. It's implementing a system that works on it. So, with that said, we have to clearly and concisely convey a message, right? So, one of the things I want to talk about is some of the best parts of social media and some of the worst parts of social media. So everybody knows, most of the people know what this one is. That's Facebook. Some of you might know what Twitter is. And I bet there aren't many of you know what Instagram is, but I might be wrong. But I can tell you that platform has allowed Noble Foundation to work with more people across the country because it's an excellent way to get out information. We have soil health groups that have started in western Oklahoma that are meeting multiple times per year. They're sharing information. They're sharing ideas. What worked, what didn't. Real time. Justin Dudgeon, you heard him talk, is driving his combine, looking at his yield monitor and posting it on Facebook. I mean, they're learning as they live. At the same time, there's information like this that is out there. And this was posted this year by a person that knows better, but they did it anyway and said statements like, "You will lose all your soil aggregation in 1 year if you don't do all the soil health principles." Guys, that just isn't true. If you don't graze a paddock, there's people that are managing for soil health that aren't even integrating livestock yet they're still managing for it. There's places they can improve. Point is, we need to be careful with what we say on a platform that's so widely utilized. I don't know where Jim is, but Jim is one of the admins on that group, and they've got people from multiple countries all over the world that are looking at what Justin Dudgeon does in western Oklahoma through that platform. It's outstanding. We just got to be careful with it. So soil health management also, as we talk about those things, needs a balance, right? So it needs a lot of this. Forget all the reasons why it won't work and believe in the reasons that it will. I said at the tour yesterday, to a gentleman, if you don't want this to work, it's not going to work. If you don't believe it's going to work, you're right. It won't. But that's the first step, is understanding that these tools, we can work them within my system, taking in all this information that you're getting, take a deep breath, step back and say, how do I fit this into my reality? Right? How do we make it work in my operation? But for every producer presentation that has outstanding results, this is what we don't have. I keep pushing the wrong button. We need more data. Data helps tell the story. We can tell the story, but if we don't have the numbers, a lot of times, I've heard this many, many times, we'll work with a producer and they'll say, well, I did this. I don't know why it worked, but it works. That's what led to this entire movement. Some producers in North Dakota started trying things, and eventually they started working. They didn't know why at that time. Jay Fuhrer, Gabe Brown, those guys didn't know why this stuff was working, but it did. Now we have to start adding data to things, because if we believe it or not, there's a whole lot of people out there that think we're full of it. That we're kooks, we're crazy. Who's that guy over there moving cows every day? We have to have the data to support not only confronting the naysayers, but to help us replicate what we've learned. Our experiences, replicate those experiences. Another thing I want to briefly talk about is this idea of if he can do it, then I can do it. That's true to a large extent, but let's talk about a few things. So if Gabe Brown can do it in North Dakota, then I ought to be able to do it in Temple, right? He gets more rainfall. This is the 30-year normal mean temperature for the country. So we're a whole lot different down here than he is up here, right? So this is both a blessing and a curse in a lot of different ways. We have probably 300 days of grazing, of growing season in Texas, in a lot of parts of our state. So not only can we grow things for longer, but we also, on the backside, have a lot harder time stopping that growth and starting something else, right? So we have trouble with terminations, growing terminations. We have trouble with without using a chemical to stop that growth. At least that's been our experience. So we have temperature gradients. We also have precipitation gradients. We all know that as we move west in the state, it becomes drier. So over here where Mr. Hurst is going to be largely different from how he's going to operate on his farm than the Mims Ranch in Marfa, Texas that sits right here. It's going to be a little different. We follow the principles, we can make it work. But I can't say that just because Gabe does it, I can do it just like Gabe. Here's something that we don't often talk about. This is Class A Pan Evaporation. So this is the evaporative losses that are lost through the soil and through the plants. So Gabe Brown's up here in the Dakotas you can't read that, I barely can either. Anyway, he's up here at the Dakotas at about a 45-inch pan evaporation. Right here where we're sitting in Temple, Texas, we're at an 85 pan evaporation. So that's 40 inches of lost operating capital, if you will. He can do a whole lot more on 15 inches than we can with 30. The timing is critical. Mr. Nimick talked this morning about the timing of his precipitation. We just lose it a lot faster. It gets a lot hotter and a lot drier here. So there are living examples in this room of making it work in Temple, Texas. But what I'm cautioning us all about is taking the idea that just because it works over there that it will. It can work, but it's going to work within our framework. It's going to work within our environmental constraints, and it'll work under our goals and objectives. If you're interested in this kind of stuff, there's a really good publication by Dr. Robinson and Nielsen. I highly encourage you to read that article. It's called The Water Conundrum of Planting Cover Crops in the Great Plains. If you get a chance to, you can Google it and pull it up. It's a really, really good article. So, let's talk a little bit about our experiences. And again, I'm going to talk about kind of some case studies of what we've learned, how we've done it. The first one being a project that we put together at Riesel, Texas. Riesel, Texas is about 15 miles east of Waco. So that way about an hour. This is, as I said, a partnership with NRCS, the Texas Grazing Land Coalition, and the Ag Research Service. So at the time, this property right here is owned by ARS, and they've owned it since 1935. They've conventionally and traditionally operated those acres. From the grazing side of things, they have continuously grazed it. All the gates are open. They have used inorganic fertilizers with liberally, if you will. They have also they have on the cropland acres. They've just planted cool season oats and grazed, and then they fed hay all winter, where they had forage deficits. Years and years and years and years of that have led them to about 5 years ago coming to us and saying, I don't have any more capital. I'm going to have to fire one of my hands. I can't make enough money. We've got to figure something out because the risk associated with everything that we're doing is not working for us. So we thought we'd try something out. So there's a lot of things that we learned from this project, a lot of things that we did really well, and some things that I sure wish we would have changed. The good thing about this is we're 5 years into it. This is a 10-year commitment from the ARS, so we're going to have 10 years of data. That's a really big data set for those of you that aren't in science, and in most of the data we see are 2 and 3 year projects. This is going to be a 10-year data set, so that's pretty cool. So where did we start? Here's where we were. Again, we were feeding a bunch of this substitution feed. Hey, we were feeding it in rings down there. We had all the gates. Every one of the gate on the place looked like that. It was wadded up in the corner. All of them are open. So when we started, I tell you what, can you go back 2 slides to where it showed the map right here? This is a county road right here. So we basically split the operation. This down here, as we'll call from now on the South Ranch, is the ranch that we just continued to do all of the traditional cultural practices. Hay, fertilizer, all of those. On the north, the acres that are not shaded, some of those are cropland acres, some of them are pasture acres. This is where we did the enhanced or the conservation planned deal. Okay. So what did we do? We split the ranches, and on the north, we attained forage animal balance first. So we reduced our stocking rate by 30%. We were overstocked. We could not produce out of the ground enough forage to support the animals that we had. So we backed off on our stocking rates by 30%. We increased our grazing distribution. We had all the gates open, and we had 2 herds. We put all the cattle together, and we instituted a 14 pasture, 1 herd system. So a typical rest rotation system. We used high stock density when we needed to, but we didn't use 1 million acres. We tried to have a typical rest rotational grazing system that we felt like most producers that was a less than 500 acre operation would implement. We used high stock density when we needed to, and I'll show you some of those instances. We integrated diversity on the cropland. So the cropland acres, we used multi-species covers. We reduced inorganic inputs, and we reduced or eliminated the feeding of the hay. And again, on the south, we continued those other practices. So how did we measure it? From the forage responses standpoint, we measured, we had forage inventories, we had grazing exposures, we measured the livestock responses with body condition scores, and actually we took fecal NRR data to look at how the crude protein dynamics look over time in comparison with body condition scores. But what we'll talk about today are these two. What did we do to the soil health? How did we measure that? And then what matters, right? The economics. So, just a few highlights of some as we went through the project of kind of what we did. We also had the idea that we wanted to fix Bermuda grass pastures that were degraded, that were not properly managed like a typical Bermuda. If you're operating under typical conditions, soil testing, fertilizing, things of that nature, they weren't done that way. There was about 20%. This is a 5-acre pasture within that system that was degraded Bermuda grass. We went in on December 2011 and we planted this multi-species mix. On April 18th, it had produced 5,500 pounds of production on top of the Bermuda grass. We wanted to see if we could fix it with plants and cows instead of all these other inputs. So we grazed that pasture with 30 cow-calf pairs for 10 days. That's at a rate of 6 cows per acre. Then we rested it for a 60-day. We just went through our rotation. And then when we got back to it, we grazed it again. We grazed it for another 15 days. So that 5-acre Bermuda pasture allowed 25 acres of grazing on 5 acres in a period of time when historically they wouldn't even use it because it was dormant Bermuda grass. So I got basically a month of resting all of my other pastures while I was in there. To me, that's good enough. But what we wanted to do was help the Bermuda grass. This is the summer following the first year of cover crop. So the cover crop was intended, right, to fix some nitrogen to help, once it desiccates and it releases that nitrogen, to help the next plant, which is the Bermuda. After the first year, this is what it looked like. 50% increase in Bermuda grass density. We did it again. The second year, now it's up to 70% Bermuda grass density. That's in 2 years. Now, it's not all Bermuda grass. There's still some Texas wintergrass. There's some Johnson grass in there. I don't care. I'm not selling horse hay. I'm selling forage through a beef animal. That is beautiful to me. I want to grow grass and I want to do it in the most economical, cheap way possible. The interesting thing is by that third year, this little guy showed up. That's big blue stem. Big blue stem started to creep into the edges of this pasture. What's that tell me? Big blue stem is highly dependent on mycorrhizal associations. That means we're starting to fix some things. We're starting to build those fungal relationships in that field. On the warm season cropland, so we're on the cropland acres, we're double cover cropping them. So we'll have a cool season mixed cover and a warm season mixed cover. This is what we did on our warm season mixed cover. This is the mix that we used. About $32 seed cost per acre. Just an idea of what it would look at before we grazed it and then after we grazed it. We typically grazed it with those same 30 head on 4-acre paddocks, and we left them in there for about 3 days. We weren't moving cattle every day, but we'd move them every 3 days. Second year, we added in some forage sorghum. You can see right here, this section had not been grazed yet. This section had been grazed. Basically, on our weaned calves, we gained 2 pounds per day on the weaned calves. With the calves that were still on the cows, they gained 2.9. At the going rate in 15, that added us an additional $115 per acre. Now, we have a large seed cost on those because we're double cover cropping them. I'll come back to that. So what about the soil health? How are we affecting all that? This is where some of the head scratching is going to come into play. So this is the water extractable organic carbon for the north pasture, the enhanced Pasture. It's already in perennial grass. Why water extractable organic carbon? So we all know that microbes are are driving these systems, right? Microbes only function in solution. They have to. They only function in solution. So organic matter is great, but I want to know what the water extractable organic carbon is, because that's the solution, the food that's in solution that they can immediately utilize. That's their food, right? So over time, this was the North Pasture, but this was the South. We're seeing small increases in water extractable organic carbon, but really no difference. What's that tell me? That these pasture systems are already have a lot of carbon in them because it has a perennial root system in it. So, and it also tells me it takes a long time to build carbon. Now, you see this and you're scratching your head, but I'll ask you this question. So those numbers tell you there's not a whole lot of difference. At the time those samples were taken, at the end of the 2015, that's what the South Pasture looked like. They had already started feeding hay, all the gates were open, and you could see cow pies before you could see grass. This is what the North Pasture looked like because of our rotational grazing system. Now, which one do you want? I want that one, right? I've got banked carbon, I've got forage that will last me into the winter, reduce my costs on other things, on that supplementation. Now, let's look at the organic carbon on the cropland. Remember, this is double cropped. So this is, the red 9 is the North Ranch. On the south, they basically left it fallow in the summer. It was tillage, and they planted oats. Here, we start to see some increases. We're starting to build that organic matter as opposed to the tillage and oat system that's typical to the region. Now, we didn't build 6% in 2 years. We didn't build 6% in 5 years. So as we talk to Dr. Haney, a pretty good conversion is we're looking at parts per million of water extractable organic carbon over here. Basically, the conversion is 1.3% organic matter for every 100 part per million increase in water extractable organic carbon. So every time we increase 100, we're increasing 1.3% organic carbon. If you look at my increase in the red, I increased about 0.5%. Everybody's going, oh, 0.5% in 5 years. That's 10,000 gallons of water that this cropland will now hold, more so than it did when we started. Remember, 19,000 gallons of water for every 1% of increase in organic carbon or organic matter. Even if we're only increasing at 0.5%, that's 10,000 gallons of more water we're holding and utilizing for plant growth. I'm happy, but my data is a little bit different than other people. Now, keep in mind, we're doing a rotational grazing systems that's less intense. We're not running 150,000 pounds of live weight per acre. We didn't high stock density graze them. We moved cattle every 3 days. Can we do that maybe a little faster? I don't know. We didn't. We managed it like we thought most producers would, and that's the results we got. Here's the results that really make me scratch my head. So here's the North Ranch, here's the South Ranch. Look at the costs. These are real numbers. Our labor on the north, the enhanced, the moving cattle every 3 days, much less. The feed, much less. Got some vet bills in there. Miscellaneous, that was the sampling and some cost for some fencing. The buying cattle cost is something I'll talk about in a second. Less machinery and fuel, more seed because we're double cover cropping. Whole lot less fertilizer, less chemical. The total costs, though, are much less. So we had less risk associated with this practice than we did over here, right? Less money tied up. When we sold our calves, This was the revenue of each one of these. Y'all start to see a pattern here? Neither one of them made any money. I know it's surprising to you. We didn't make any money in the cattle industry. But point is, there's a whole lot, there is less money lost in this system than there was in that system. Now, where did we make the mistake? Did we miss out on opportunities? Yeah. And I'll tell you what those are. Let's process some of these thoughts. Where did we miss out on opportunities? Gabe Brown said something one time that was really, really important. He said, you guys work your tails off to build all this organic matter and build all this forage, capitalize on your rewards. When you have excess forage, capitalize on it. Go buy stalkers, go buy more cattle, and convert that plant, that sunlight, into a marketable product. The beef that we sell and we raise our families on, right? This comes back to one of these concerns that I have. We were so myopic in our thinking that, number one, I'm not increasing the stocking rate on this ranch until I can make it through the winter without feeding any hay. That was my first rule. I made a mistake. The second rule was, I was so focused on building organic matter and building organic carbon that I left a lot of forage, even above my 50% residue line. I left it in the field. I could have utilized it with yearlings. I could have utilized it by buying some heifers and breeding them and then selling them. There's 1,000 different ways we could have made money on that forage, but I left it because I thought I can build carbon that way. And I did. But I also didn't make any money. So we got to keep in mind that this is a business. We're in the business of making money. Also, timely applications of inorganic fertilizer should be considered. I didn't say we need to be doing it every time and 3 times after every cutting the hay or whatever you're doing. Consider it. We've had a considerable amount of success by adding in-row phosphorus at the time of planting with our cover crops. Why? Phosphorus is critical to seedling establishment. It's just helped. We've had a lot of success with that. And also, I think this idea that we can just go cold turkey, no inorganic fertilizers, has hurt us a lot. We went cold turkey. We added one application of 2 tons of chicken litter out of 5 years. One application on one field. No inorganic. I think if we would have used some strategic applications to help those covers get started, we would have been all right. Also on that economic deal, that was a 5-year rolling average. Okay? There were years we made money. There were years that the North Ranch made more money than the South. And typically it turned out to be a $20 per acre difference. Because of that system, we made $20 more per acre. You start to scale that out into a large operation and you can start to see some dollars. That was the 5-year rolling average, though. It is what it is. Also, I think we could progress towards spring calving. We have a fall calving herd there. So we're dragging a wet cow through the winter at the time where it's most critical for her and her nutrition needs are highest. So we're feeding hay through the winter and all those sorts of things. So if we could progress through to a spring calving cow herd, I think that would help us. And again, just being patient. Resilience is not built overnight. I think that we're going to have to be patient if we're going to see this thing through. Okay. Let me talk about another experience that we have, and it kind of flows into what we see within the Southern Great Plains. So we talked about kind of a small landowner size effort within that cow-calf sector. Let's talk a little bit about the other sector of the livestock industry that is so dear to a lot of us, especially in Oklahoma and the Southern Great Plains, and that's running yearlings on wheat pasture. We're really good at it in Oklahoma. We've done it a long time. But there's some concerns with that. And is no-till better than tillage? Should we be using cover crops in the warm season? How is that going to affect our wheat crop? All of those sorts of things are questions that we've been asked. And Dr. James Rogers is one of our principal investigators. He's in the crowd somewhere right over there. So if that isn't nerve-wracking, I'm giving a talk of his information and then he's staring at me. So here's what we're going to go through is some of the work that Dr. Rogers and his team has put together. So let's look at what the literature tells us, right? We're trying to build some data here. And what has currently been done, Nielsen in 2016 did a review of a whole lot of cover crop research in semi-arid regions on the effect of water yield. So that's what the concern is, right? Are the warm season cover crops going to use all my water and I can't get my wheat germinated, and so I could get my cattle in the fall, right? So of the 27 studies he looked at, 22 of them reported decreased yields. 1 said there was an increase in yield, and 4 said both. Well, what's the research tell us? Can you tell anything from that? Not really. So we're going to do our own research and kind of see where we're going. So the objectives for Dr. Rogers' study was to measure the impact of summer cover crops on winter pasture production, wheat pasture. Monitor the change in soil health, and then evaluate the economics of that system to see which one of those worked better. Now, we wanted to do it under a typical type system. So we wanted to manage our wheat pasture like most of our wheat pasture farmers are going to manage there. So we would take a typical soil test, and most of our soils don't need the P and K typically for wheat pasture, and we're applying 120 pounds of N. Our seeding rates are about 120 pounds per acre. We try to get it in by September the 15th, and we'll till or no-till, as you'll see right here. Here's our study area. This area is 100 acres. It's not a plot. Each of those units are 10 acres. And the treatments are no-till winter pasture with and without a summer cover, and then tillage winter pasture with and without a summer cover. It's on a silty loam soil. Here's the typical timeline. So we've got, we plant our wheat in September. We try to start grazing in the middle of November, especially we sure like to have it in before Thanksgiving. We graze through the end of April, and then in May, we've got to hurry up, get the ground in, get our warm season cover so that we can get some growth, get some sort of a grazing period, and then we've got to terminate it again and plant wheat in September. That's our time frame. This is kind of what we planted for the warm season mix. You'll notice the lack of sorghums. We tried to stay away from anything that was going to have a prussic acid issue. Maybe we sacrificed some production, maybe not. That's the going thesis, is that you might, but we didn't want to worry about prussic acid issues, so we went with more of the millets. Baseline soil test. Information, percent organic matter, we're sitting, right around 2%. Haney test scores, our nitrogen, our Slavita CO2 respiration, that's the activity, the microbial activity within the soil, very similar. Then the soil health scores are also very similar. So, what's the data going to show us? So we planted our wheat, this is last year's numbers, we planted our wheat, and then we started measuring the production in November, early November. Stalkers went out in early December, and as you can tell, the red bars are the no-till. The no-till consists, these little error bars, if they're separated, that means there's a statistical difference. It means you can scientifically say that at this date, no-till was different than tilled. So, as far as production over that time frame, no-till outproduced the tillage wheat production. As far as animal gain per acre, 454 total pounds of beef produced per acre on the no-till, significantly less on the tillage. Now, the question that we worry about is, what about the water? So, in that spring period, February through May, at a 3-inch depth during the winter, the red line again continues to be the no-till. It's higher, but it's not statistically higher. So in the spring, it wasn't holding that much more water. This is 1-year data. In the spring, it wasn't holding that much more water than the tillage. Let's think about temperatures. We tend to think that the tillage are going to be higher, right? It's going to have higher temperatures. The no-till will be cooler. It is cooler, but only at a few dates is it statistically lower. That's the first year. Yes, Chris. It's not a first year no-till. Those no-till acres have been no-tilled for how long, Dr. Rogers? 10 years? 12 years. Okay. Here's the head scratcher data though. Everything was tracking just kind of about right, but the infiltration data is interesting. So mean tillage, no tillage, infiltration rates. The tillage had higher infiltration rates, and we were using the infiltrometers. We weren't just sticking a ring in the ground and pouring the water in. We used infiltrometers, and that's the data. Again, this is 1-year data. We like to see long-term data sets, but year one is still year one. Next year, this data set's not going to change. Next year might be different, but year one data is year one data. So that was through that first winter period, right? Then we went in and we planted our warm season cover crop. So for the no-till acres, here's kind of what it looked like. This is no-till with no cover crop. This is no-till with a cover crop. Here's another picture of it. So we had a fair amount of residue. Here's what our tillage systems look like. This was till with no cover crop and tillage with the warm season cover. So we grazed those warm season covers, and we got basically a month of grazing, a little less than a month of grazing out of it. Again, the no-till system produced more beef per acre. This is interesting though. On those no-till acres, these are the mean plant separations for tiller cover crop and no-till for those cover crop paddocks. So basically, of the total biomass, what kind of plants were in the pasture? So where we had tillage with a cover crop that we grazed, 58% of that was the cover crop. 26% of that, was the cover crop. Other is 26%. So other annual grasses and other annual summer grasses made up 26%. Where we had no-till, the vast majority of the forage that was there was either litter, was crabgrass, it was other annual grasses that grew. We didn't get a very good stand of our cover crops that we planted. Yet, they outproduced the tillage cattle. So they were grazed longer and they gained more on our summer annuals that Mother Nature gave us rather than the ones we planted. That's a blessing in disguise. So, really where we want to know is what's the water deficits and what's the water changes during the summer though, because that's going to affect our next wheat crop, right? So, during the summer months, here we go. During the summer months, this is the mean tillage and no-till, 3-inch volumetric soil moisture. Here we are, we're starting to see some separation. In our no-till fields, we're starting to hold more water than the tilled fields. The red are no-till and the blues no-till. Again, we're starting to see that data start to get in. The tillage fields are statistically hotter during the summer than the no-till. We would expect those, right? We would expect them to be cooler and hold more water. We're starting to see that. That's what matters, and that's what we wanted to see. But how is that going to affect us? Again, here's that head scratcher infiltration data. This one, no-till cover crop, should be the highest infiltration, right? That's not what we're finding. We found on this that it was the lowest infiltration year one. Why do you say that? This is the first year, I believe, that field had been grazed. It had been no-till but not grazed. Is that correct? In the summer. So we think we think we built up a little bit of compaction in the summertime. And what we're going to do is we'll be testing bulk density measurements next year to kind of see where we're headed with that. If you don't have the soil aggregation and it's grazed like that, the first few years you can see some compaction. But once you start to build that aggregation, it's much less of an impact. So, how did the summer... Another thing is, this is interesting. This was flown a couple of weeks ago with our drone. This is the study unit. So, how did it affect this year's wheat production? This picture is a real-time picture, or not real-time, but it was taken the first week of November. You see these paddocks like this? These lighter paddocks, that's where we had the summer cover crop. They're marketably behind the other tillage fields in wheat production as of today. So this was the production. This data was from November the 10th. So the no-till fields did produce more than the tillage fields. But when you look within those, the no-till, where we had the cover crops are producing less than where we did not have the cover crops. So if you're a producer and you want early wheat, that's something that you need to know. It might slow you down a little bit until that system gets going. This is the data that we have, year one. That was some of the valid concerns that people had. Is that going to slow me down if I've got a contract for cattle that I got to turn out Thanksgiving? That's kind of what we're seeing, is it'll slow down. Now, by spring, when we're really ginning and growing wheat, is any of that going to matter? Probably not. We're probably going to be producing just as much wheat, especially on those cover crop acres, but early in that season it might matter to you. What we like to see, this is a slide that I got from NRCS that I think really kind of tells the story of both of those projects, the research and the study. Soil quality improvement over time increases as we increase time. So the first thing that we start to see is near surface soil carbon. So we start to build residue, right? That's the first principle, keep the ground covered. Then we start to build aggregation. Then we have water and nutrient holding capacity increases because we're starting to build organic matter. And you'll as you see, productivity is the last one, and it's further on down the schematic of time. So over time, we start to build those. Now, I got a few minutes here left, and I want to talk about kind of where the outlook for the future is. What are we doing at the foundation that is going to be, I think, really exciting for all of us in this movement moving forward? For those of you that don't know, we have, you heard Adam talk a little bit about it earlier. We have a plant biology division at the foundation that works on a lot of really kind of new cutting edge experiences. And Dr. Kelly Craven and his group are working on some really cool mycorrhizal fungi work. So we all know the benefits of mycorrhizal fungi, right? So the mycorrhizal fungi infects the root hair of the plant. And that in turn, that plant gives the fungi sugars, and the fungi gives the plant the ability to get more water, to make more nutrients available. It can help you tie up pee. It's just a symbiotic relationship within the plant world that is number one, astonishing and really exciting to us in the soil health effort. But it's something that Dr. Craven has been trying to figure out, how can we make it more, how can we integrate that more into our agronomic practices from a low input standpoint. So Dr. Craven, his entire research project is based around the understanding that we have microbes in our body that help our health from a human health standpoint. The same thing works for plants. Plant microbes help plant health. So this Symbiotic for Sustainability group, this is Dr. Craven right here. The rationale of his efforts is that they understand that plants depend on different type of symbionts, all in the natural environments, especially the challenging ones. So Chris Nimick talked about our prolonged drought and our almost somewhat violent rainfall events. Would anybody say that the ranching environment's not challenging for a plant? You got to respect these plants that can grow in really challenging environments, and we have one here in the state of Texas. So what he would like to do is find these symbiotic microbes that promote plant growth under a sustainable, low input strategy. So how he's doing that is working with mycorrhizal fungi. So we've been working in the area of fungi for a lot of years, 20 plus years. Most of you are familiar with some of the endophytes in tall fescue. We've been working with those for a long time. We're really getting turned into this mycorrhizal world basically because of this ectomycorrhizal fungi that he's been working with. So what's the difference? Endomycorrhizal are things like, most of you have heard of arbuscular mycorrhiza, right? So that's the ones that's in the soil but the difference is arbuscular mycorrhizal actually penetrate the cortex of the root cell. And it makes that very difficult to isolate and to recreate and culture that fungi in a lab. So you can't build that mycorrhizal fungi because of that property. The ectomycorrhizal, they do not enter the cell wall, but they provide all the beneficial, all the benefits to that symbiotic relationship without doing it. Because it doesn't go into that cell wall, it makes it much easier to culture that fungus in a laboratory. Then the idea is that we can then add it to seed coating maybe, if we're benefiting, or some sort of a way to get that specific isolate of mycorrhizal fungi out to benefit whatever we're going to work on. So we understand that we can culture it in an artificial media. One of the things that is interesting about this is the specific mycorrhizal that he's working on was developed by Warcup back in 1981, and he found a specific strain of mycorrhizal fungi that was endemic to an orchid in Australia. And subsequently, they've found that not only can it be artificially inoculated to root systems of other plants, but it could also benefit pronounced growth effects and increase stress tolerances to those plants. So Dr. Kelly Craven said, well, let's go get that strain and try to work on it here at the Noble Foundation. So he ended up getting Sebacina vermifera, that orchid isolate, brought it to the foundation, and we started working on it with Alamo switchgrass. He started some of these trays of Alamo switchgrass, and he inoculated that Sebacina vermifera onto 10-day-old seedlings right here. 10-day-old seedlings. After 8 weeks, 94 to 100% of them, of those seedlings had been affected and built that symbiotic relationship. So you can see right here that mycorrhizal fungi has gone into this big root hair and infected that site. Once it does that, then it can start to build those further benefits. You hear some some blown up images through his microscope of just how that fungus is going in and working in between those root hairs. So as you look at this data, here's the Sebacina inoculated on the switchgrass. This is not a Duck Dynasty contest, these are roots. If you look at that one in the middle, that's the switchgrass that was grown without the fungal benefits. All of these other 6 are the different isolates of the Sebacina that were applied to these switchgrass roots. So a lot more productive root production, right? And as we grow more roots, we tend to grow more shoots, right? More vegetative production. We see that even under drought stress. So as we look at this data here is under normal watering. This is the production of the switchgrass plants with the Sebacina and without under normal watering. Under drought stress, when we start to turn the water faucet off, it still outproduced the plants that did not get the Sebacina inoculant. Now, since then, he's developed another strain. Come on, here we go. He's developed another species called Sebacina besseyi. Sebacina besseyi is also an ectomycorrhizal fungi. It can also be cultured. And he tried it out on the switchgrass. After 8 weeks of colonization, 12% more shoot length, 9% more root development, almost 20% more fresh shoot weight. That's biomass. So if you had something you could put on and grow 20% more production, would you like that? Through a symbiotic relationship that happens in nature? I'm a buyer. And we don't sell it. We're just doing this for free, for research. So, biomass. Increase on winter wheat. Will it work for winter wheat if it works for switchgrass? Here we are. These plants were inoculated with Sebacina. We didn't see much difference after the first harvest. Then we start to see some differences. As the week progresses, as the plant starts to build that root system, starts to see those benefits, we start to see more production in wheat. Those are two grasses. Will it work for legumes? Here it is in alfalfa. Again, more production with the inoculation versus without. And these are cultured mycorrhizal fungi that have been developed in the lab and added to these plants. So, guys, we've got a lot of things to be thankful for. We've got a very exciting future in this area of soil health. I think we need to focus on these three S's, if you will. Science. We got to have the data to debunk the naysayers. We got to have the data and the understanding and the scientific background to be able to understand why soil health works on the Nimick farm and why soil health works on Mr. Hurst's farm. Have the data to back that information up. Then we start to build that legacy of stewardship over time, and then that will improve and solidify our sustainability into the future. So, with that, I thank you. I thank you for allowing me to be here today and speak with you. My contact information is on here. If I can ever help you, I'd be happy to do so. Thank you for your time.